so let's see if we remember all we know. Zoom in
When
already.
is our test?
Huh?
When is our test about this?
I don't know. Maybe next Friday.
Oh.
Okay, so the central angle. What do we know about central angles?
It's in the middle.
It's half the degrees of the arc.
No.
It's the same as
No, that's the things on
Or,
the
yeah,
side.
yeah.
Okay, central angle is equal to its arc.
Here.
Okay, what kind of angle is this?
inscribed.
Inscribed angle. Inscribed angles are
Half the size.
half of their arc that they intercept. Okay, so those are the two old ones. Here's a kind of new one. I don't really think of it as new, but I guess it's going to confuse people. We'll say that now. All right, you guys remember what this kind of line is called right here?
I can't see. Oh, that's
tangent.
just.
Tangent. So when you have a tangent to the circle,
It's a 90 degree.
well, no, that's okay. Let me back up a little bit.
It's literally.
When is a tangent 90 degrees to the
When it hits the radius.
when it hits a radius at
That
the
is
point?
literally the radius.
Okay, this is close. I mean, I didn't draw a perfect circle. It is really close. I probably should have drawn it like more out here. Okay, anyways, so in this case, it's not 90 degrees, right? Now that I've moved it.
Because it looks like a chord.
Yeah, it's just a random, it's when it goes through the circle, they call it a secant. But yeah, this was called a tangent. So it's the same thing as an inscribed angle though. Because it's an angle with the vertex on the circle. Okay? And so therefore, if this is like, I don't know, what does that look like? Maybe 130 or something like that. It's still going to be half of the arc that it intercepts. But the arc it intercepts is all this. You guys see it? So this angle is going to equal half this arc, just like an inscribed angle. They don't call it an inscribed angle, but it's still on the edge of the circle, so it's like, and it still equals half the arc that it intercepts. It mostly just looks different.
Here's one
Indeed.
is not. That's not true.
So if this is 130, we could say this is 360 minus 130. So this is like 230. And this angle over here would have to be half of that.
What did that help us with though?
I was just kind of giving you another visual. Okay, that's not all we're doing. One thing, I'm barely doing that at all, really. The other thing is, okay, is this a central angle in here, like right
I
now?
can't see.
No, it's not a central angle. Is it an inscribed angle?
No.
No, it is neither. Okay, it turns out, I don't know the proof for this one, but it turns out that this angle right here, X, is going to be like the average
Between the inscribed and the.
of these two arcs.
Oh.
Okay, so the arc that's intercepted on this side, and this has to be X over here too, right? Because they're both, they're vertical angles. So however many degrees this will be 2. But to find this angle, it's going to be the average of the two arcs that it intercepts. So let's say this looks like maybe 70, and we'll say this is like 30. So angle X would be equal to 70 plus 30 divided by 2. Okie dokie. 70 plus 30 divided by 2. So how could I find an angle Y then?
That's just use
180
180.
minus.
Yeah.
Right, if X is 50, Y is 180 minus 50, because these two together make a straight angle. They like to ask questions like that. You don't necessarily need these two arcs to figure out Y, although Y would be the average of these two, this and this. But since we know X, we don't really need to do that. Alright. The last one, so this is when two secants meet somewhere in the circle. It's not in the center, it's not on the edge, it's not inscribed. It's just kind of floating around. Okay, and then the last example, the last thing for today, new thing for today, is when the two secants meet outside the circle. Let's say we'll keep it simple. This is about 100 degrees, maybe this is like 40 degrees. Okay, to find angle X out here, you, instead of adding them together and dividing by 2, you have to subtract these two and divide by 2. So X equals 100 minus 40, whatever that is, divided by 2. 60 divided by 2 is 30 degrees. Okay. Now, the way they make these harder is they turn it into like algebra problems.
Oh.
But like, they put the X there or some different places. But we'll figure it out. You guys fear no algebra, right? Right, Easton? Okay. Actually, another way they make it hard is put a ton of lines on the same picture. Let's turn to page 379 if you haven't yet. Number 7. Okay. Yes, good mess. These are matching. It's A, B, or C are the 3 options. So, is the angle going to be half of the intercepted arc? Is it going to be half the sum, or is it going to be half the difference?
The difference?
Okay. Well, when is it going to be half the arc?
When it's inscribed.
When it's inscribed. When is it going to be half the sum?
When it's the other.
When they meet somewhere inside the circle. It's going to be half the sum of the arcs. Okay, when is it going to be half the difference?
When it meets outside of the
When it
circle.
meets outside the circle, the angle that's created is half the difference. So, meets inside, half the sum. Add them together, divide by 2. Meets outside, half the difference. Subtract and divide by 2. Okay, so number 7. Angle 1 is what kind of angle?
Outside.
It's outside the circle, so it's going to be
C.
C, half the difference. It's like my last example here. Now, one of the lines is tangent to the circle. That doesn't really change anything. You still do the far arc minus the near arc divided by 2. So, what I mean by the far arc, this is the angle, this is the far arc minus the near arc. Just this divided by this minus this divided by 2. Okay. Number 9. What kind, angle 3 is what kind of angle?
Inscribed.
Well, it's kind of like an inscribed. I would have just called it inscribed because the vertex is on the circle. So it's going to equal half of its arc. So that is A.
Is there a name for that?
They didn't name it, no. Not everything has a name. I would just call it, I think they should have just called it inscribed, but it's kind of outside the circle, but so it's not really inside necessarily. Anyways, number 11, angle 5. It's outside the circle, so it's C. You have to subtract and divide by 2.
So number 3, since it's like touching a circle, is just an inscribed.
Yeah, it's like an inscribed, even though one side of the angle is tangent to the
So
circle.
no matter how goofy it looks if it touches the circle, like.
If the vertex is on the circle, you do half the arc. So angle 3, if we were trying to find it, would be half of that arc on the right side, whatever it is. Okay, what are we on 13? Angle 7. Speaking of,
Wait, let's see, where's angle 7? Oh, that's
A.
A.
yeah, angle 7 is like angle 3. It's kind of like an inscribed angle. It's on the circle, so it's going to equal half of its arc. Number 15. Angle 9. Okay, yeah, this is the first one we've seen. It meets somewhere floating around in the circle. It's going to be half the sum of the arcs, intercepted arcs. Look how fast we're going. Easy peasy. All right. I kind of wish we would have started with 16. This 17's picture looks a little bit confusing. You guys know what's going on in 17?
It's a outside, or tangent, no.
One of the lines is tangent, that's true.
And one of them is
One of
outside.
them's secant.
Oh.
But they're meeting outside the circle, and they put a Y right here. Well, if this is Y,
The other one's not.
this is Y. So, what kind of angle is this? Is it like an A, B, or C problem?
See,
It's a C. They're meeting outside the circle. So we gotta do like this arc. Now, since this is tangent, the arc goes all the way from, like, here's the point of tangency. Here's the point on the secant. So the arc goes all the way from there to there.
Yeah.
So we do far arc minus near arc divided by 2. That would give us this angle. So what are those? 250 and 64.
250 minus 64 is 186 divided by 93.
Okay. 250 minus 64 divided by 2. What'd you get, 93? Alright, 93 degrees. 19. Okay, 2 tangents. That doesn't really change anything, the 2 tangents thing. Looks kind of like a fish.
it's missing something. What was number 15?
It's not missing that much. You just add an eyeball right here.
This one is
Little fishy mouth.
I can't see.
Maybe a fin up here.
I can't see.
There. It's a perfect spitting image of a fish.
Isn't it, since it's the whole circle, like it covers the whole thing, you do one, like,
Yeah.
you do 360 minus 112 to find the other angle.
Right. Good observation. So they said this is 112 right here.
I think it's 248.
So how do we find, if this from here to here is 112, how do we find the major arc?
360 minus 1.
360 minus that. What'd you say, 248? Yeah, that sounds right.
It was written in there.
So we're doing, kind of like number 17, we're doing far arc minus near arc divided by 2 equals angle. 248 minus 112. What does that come out to?
68.
Alright, I'll just put it over there. Alright, 21. Alright, is 21 the same kind? Now, I notice 16 is the only one like it. So how would we do 16?
16, you just do 82 plus 74.
Right. On 16 you add and divide by 2 since it's inside the circle. But what should we do on 21?
You do 130 plus 140 and then you, whatever that is.
Yep.
No, like
It's
you,
incorrect. So it's 360 minus 130
Right.
minus 240.
Now, yeah, it's on the circle, so it's like yesterday. It's an inscribed angle. Oh, you were
if
saying
you
how to
let
find
me
the arc.
finish, I was gonna say you add those and then subtract it from 360, but no.
Okay, so yeah, 360 minus these 2 will give you the missing arc. 270, 360 minus 270 is 90. So if this arc is 90, this, yeah, will be half.
Whoever made these directions were like,
It just says solve, write an equation and solve. So 23, this is where the algebra starts.
Well,
They're not putting x, they're not putting the variable on the missing angle, they're putting it on the arc. So we're gonna have to do a little bit of algebra. So how would, well, I'm not gonna solve 22, but how would 22 set up?
86 plus x over 2 equals 36.
Close, you made a little mistake. 86 what?
Minus.
Minus x over 2. So equals the angle out there, which is 36. Okay, so that's how you'd set it up, but I'm not going to do that. It's a lot of these are going to work out the same way though, so you kind of can repeat. Okay, 23 is inside the circle, so how would it set up?
85 plus 61.
No,
85 plus y
Yeah.
equals over 2 equals.
right. 85 plus whatever the y arc is divided by 2 equals that middle angle, 61. All right, you algebra geniuses, how do we do this?
Those 2.
Yeah, if the whole side is divided by 2, you want to get rid of that first. So we can just times 2
Minus 85.
to get 122. Yeah, get rid of the added 85. We could subtract 85. 37.
If you get negative x equals, do you just change it to a positive?
Yes, well, yeah, if negative x equals something, you just switch the signs on both of them. Positive, negative, or vice versa. All right, 25. Yeah, you shouldn't get any negative answers today because
Can't have negative.
there is a negative degree thing in some situations, but it's not on this. All right, so how would 25 set up?
25.
Clayton, why don't you try? I'm gonna start calling you Clayton. Clayton.
Shit.
It's in science. Because Clayton.
No, but
No.
bro.
Okay, did you hear what we said on 22? Remember what we said?
Well, I wrote it down.
So it,
Just switch the numbers then.
so look on 22. Okay, on 22 we did 86 minus x over 2 equals 36.
So, like, would be, we just flip the number, so it's equal to x?
On 25,
Yeah,
there's no x.
or b?
So yeah,
What?
so what would the equation be for
So,
25?
56 minus 23 divided by 2 equals b?
Nope.
Or-
Okay, watch. Here's the visual. This minus this arc divided by 2 equals the angle. So far arc minus near arc divided by 2 equals the angle.
So, b minus 56 divided by 2 equals 23.
There you go. Okay, so here are the divide by 2. We're going to times 2. And plus 56.
Or you can get decimal answers, because I'm getting there. 0.5, I got a 0.5.
Not on.
I didn't get one back.
I got 24, 25 with a 25.
I got
No,
102.
I don't see decimals. On 24 you did? That's not right.
You get 164
Okay.
plus x over.
So on 24, 63 is not.
That's the answer.
No, it's not.
63 is not. Is that.
63 is not going to be 164 plus z divided by 2.
It's going to be 180 minus 63.
Right. You do 180 minus 63 to find that obtuse angle in the middle. And then z plus 164 divided by 2 should equal that.
Wait, okay, hold on.
63 is the wrong angle to go with z and 164. It's not the right arcs. So you find the other angle that's adjacent to it.
I do 180 minus 63.
Oh, speaking of 24, 27 is just like it.
Yay.
Maybe I should, well, it's got a little more algebra on 27. So the problem is 36 should be these two arcs added together and divided by 2. But they don't give us these two arcs, they give us the top and the bottom. So
180 minus that.
So yeah, this angle should be these two added together and divided by 2. So if this is
Oh, I get it.
36,
Okay, I get it now, yeah.
this is 180 minus 36, which would be 144. So these two should add up and divide by 2 to equal this angle or this angle. Anyway, so it's 7c plus 1 plus 11c minus 1 divided by 2 should equal 144.
What the heck?
Alright, now,
You got, wait, John, you did 164 plus 117 over 2, and then you got the answer?
Where, what one?
124. You did 164
I have done
plus...
24.
it's not a decimal though.
Nice.
So 164 plus z over 2 equals 117. Right? Then you multiply by 2 first. Okay, how can we simplify this on 27?
Mix 7c plus 11c and then
Yeah.
1 minus 1 is
Add your like terms here. 7c plus 11c is 18c. 1 plus negative 1 is 0. Now, we could multiply by 2 on this one, but you guys know what else we could do? 18 divided by 2
So it's 9c.
is 9c. So we could just divide by 9. Let's see, what is that? 16. I might regret doing 31. You got some explaining to do. Alright, 29. It's not that long, it's like one sentence and 2 questions. No problem. I'm not afraid. We're not worried about it. Alright. Carolyn, how about
There's a square.
29? How would that one set up? Pretty close to 22. It's kind of backwards, but same idea.
So would it be 3G plus 6 plus, I would say 20?
No. Okay, so 22, you just go 80 minus x, or sorry, 86 minus x divided by 2 should equal that angle out there, 36 degrees. So what would 29 be then?
3G plus 6 minus G equals
Yep.
20.
Yeah, you forgot to divide by 2. Equals 20, what was it, 20? Yes. Alright, I didn't really draw that picture. Okay, what do we do algebra now?
Well, it's 3G minus G, so it's just 2G plus 6 over 2.
Okay, we could multiply by 2 like we did on most of these problems, but we also could like distribute the divide by 2. You have to divide everything by 2, you can't just divide one thing. All terms are divided by 2, so it's just g plus 3 equals 20. Therefore, g is 17. Let's bring that circle down so that I didn't use it. Alright. We kind of did did one of these earlier, remember when we had two tangents and? Ooh, missed. There we go. We got an X, a Y, and a Z. Okay, find expression for X, the measure of the angle formed by two tangent segments in terms of the stated variable. Y, the measure of the intercepted arc. Alright, so I think what they mean is we're not supposed to use Z on A. So if I don't call this Z, what could I call it?
You call it, let's see, x is equal to y plus
Okay.
y.
If this is Y,
then
this
360
little
minus
arc,
y.
right, this big arc must be 360 minus Y. So that's what we're gonna call it instead of Z. Okay, and then we're gonna set up like, they want us to say what X is equal to. So how would I set this up for X? Just like all the other problems.
360 minus y
That minus that
over 2
over 2 equals that. So 360 minus Y minus that Y over 2 should equal X. And we're just going to clean that up a little bit. What is negative Y minus negative 2Y? Now, we're not going to solve this one. We're just going to write an expression to represent what X would equal.
Can you move the distributive property?
Yeah. This is like distributive property with division. So divide both of those by 2, and it's 180 minus Y. Okay, that's our A answer.
Not the 360 minus y either. Or it is-
Hmm?
do we have-
What does B say? It says we're supposed to use Z instead of Y this time. So it's almost the exact same thing. So if this is Z, the major arc is Z, what would the minor arc be called?
It'd be 360 minus z.
Yeah, same difference. Now it will set up a little bit different because we're doing, the big arc minus the little arc divided by 2. So it's Z minus, and on this one parentheses are important. 360 minus Z
Over 2.
over 2.
And you can't simplify that?
Okay, yeah. Yeah, we can simplify it, right? Because this is Z minus
360.
Z. Okay, when you subtract all that stuff, it's like minus 360 and minus Z.
Yeah, so plus z.
So Z plus Z is 2Z and minus 360.
And then you can simplify it more.
Yeah, divide those by 2, so this time it's Z minus 180 instead of 180 minus Z. So I'll just put that down here. That wasn't so bad, was it? That is how you have to set up 30, by the way. So if that small arc on 30 is X, what could we call that really big arc?
360 minus x.
360 minus X. So you're going to have to do 360 minus X minus the little x over 2 equals 160.